Hello, everybody. Today we are going to deep into random Python library module used for generation pseudo-random numbers. Before we start, please give a like to this episode so more people can see it. Subscribe and turn on notifications so you don't miss the next episodes. Let's go. A pseudo-random sequence of numbers is one that appears to be statistically random, despite having been produced by a completely deterministic and repeatable process. The generation of random numbers has many uses, such as for random sampling, Monte Carlo methods, board games, or gambling. Before modern computing, researchers requiring random numbers would either generate them through various means, dice, cards, roulette wheels, etc., or use existing random number tables. The first attempt to provide researchers with a ready supply of random digits was in 1927, when the Cambridge University Press published a table of 41,600 digits developed by L.H.C. Tippett. In 1947, the RAND Corporation generated numbers by the electronic simulation of a roulette wheel. The results were eventually published in 1955 as a million random digits with 100,000 normal deviates. A pseudo-random number generator, PRNG, also known as a deterministic random bit generator, DRBG, is an algorithm for generating a sequence of numbers whose properties approximate the properties of sequences of random numbers. The PRNG-generated sequence is not truly random, because it is completely determined by an initial value, called the PRNG's seed, which may include truly random values. The full schema is seed, initialization function, transformation function with deterministic algorithm, output function, random bits in the end. That is how pseudo-random generator works. Python uses the Mersenne Twister as the core generator. The underlying implementation in C is both fast and thread-safe. Mersenne Twister was developed by professors Makoto Matsumoto and Takuji Nishimura of Hiroshima University almost 20 years ago. The Mersenne Twister is one of the most extensively tested random number generators in existence. However, being completely deterministic, it is not suitable for all purposes, and is completely unsuitable for cryptographic purposes. It is used by every widely distributed mathematical software package. The Mersenne Twister is used as default PRNG by the following software: programming languages, Dialog APL, IDL, R, Ruby, Free Pascal, PHP, Python. Also available in NumPy, CMU Common Lisp, Embeddable Common Lisp, Steelbank Common Lisp, Julia. Linux libraries and software, glib, GNU Multiple Precision Arithmetic Library, GNU Octave, GNU Scientific Library. Other, Microsoft Excel, Gauss, Gretel, Stata, Sage Math, Scilab, Maple, MATLAB. It is also available in Apache Commons, in the standard C++ library, and in Mathematica. Random module. For integers, there is uniform selection from a range. For sequences, there is uniform selection of a random element. On the real line, there are functions to compute uniform, normal, Gaussian, log normal, negative exponential, gamma, and beta distributions. For generating distributions of angles, the von Mises distribution is available. Bookkeeping functions. Seed, initialize the random number generator. If A is omitted or none, the current system time is used. With version 2, the default, ISTR, bytes, or byte array object gets converted to an int and all of its bits are used. With version 1, the algorithm for str and bytes generates a narrower range of seeds. GetState, return an object capturing the current internal state of the generator. SetState, restores the internal state of the generator to what it was at the time getState was called. State should have been obtained from a previous call to getState. Functions for bytes. Ranbytes, generate n-random bytes. This method should not be used for generating security tokens. Use secrets.token_bytes instead. Functions for integers. Range, return a randomly selected element from range, start, stop, step. Randint, return a random integer n is lower equals a and greater equals b. Alias for range, a, b plus 1. GetRandBits, returns a non-negative Python integer with k random bits. Function for sequences. Choice, return a random element from the non-empty sequence sec. If sec is empty, raises index error. Choices, return a k-sized list of elements chosen from the population with replacement. If the population is empty, raises index error. If the weights sequence is specified, selections are made according to the relative weights. Alternatively, if a cum_weights sequence is given, the selections are made according to the cumulative weights. For example, the relative weights, 10, 5, 30, 5, are equivalent to the cumulative weights, 10, 15, 45, 50. Internally, the relative weights are converted to cumulative weights before making selections, so supplying the cumulative weights saves work. Shuffle, shuffle the sequence X in place. To shuffle an immutable sequence and return a new shuffled list, use sample with len function instead. Sample, return a k-length list of unique elements chosen from the population sequence. Returns a new list containing elements from the population while leaving the original population unchanged. Members of the population need not be hashable or unique. If the population contains repeats, then each occurrence is a possible selection in the sample. To choose a sample from a range of integers, use a range object as an argument. valued distributions. Random. Return the next random floating point number in the range 0 and 1. Uniform. Return a random floating point number. Expovariate. Exponential distribution. Lambda is 1.0 divided by the desired mean. It should be non-zero. See examples below. Triangular. Return a random floating point number n is lower equals than low and greater equals than high and with a specified mode between those bounds. Beta variate. Beta distribution. Conditions on the parameters are alpha greater than 0 and beta greater than 0. Returned values range between 0 and 1. Gamma variate. Gamma distribution. Conditions on the parameters are alpha greater than 0 and beta greater than 0. And examples below. Gauss, normal distribution, also called the Gaussian distribution. Mu is the mean, and sigma is the standard deviation. This is slightly faster than the normal variate function defined below. Log-norm variate, log normal distribution. Normal variate, normal distribution. Mu is the mean, and sigma is the standard deviation. And examples below. Von Mises variate, mu is the mean angle, expressed in radians between 0 and 2 pi, and kappa is the concentration parameter, which must be greater than or equal to 0. Pareto variate, Pareto distribution. Alpha is the shape parameter. Weibel variate, Weibel distribution. Alpha is the scale parameter and beta is the shape parameter. And examples below. You can also use random class as alternative generator. Class that implements the default pseudorandom number generator used by the random module. You can also create your own pseudorandom number generation class, inheriting from the random class and implementing your own logic. As in the example below. Thank you for watching. Please, give a like for support this channel. Write comments, share with friends, and subscribe to see new series. Be safe. Bye.